Figure shows 3 AC circuit in which 3 equal currents are flowing. If the frequency of EMF is increased, how will the current be affected in these circuits? So what we find from the question is that, okay, frequency is increased, okay, frequency of the EMF is increased, and we are going to find how the current is affected on increasing the frequency. So when we have resistance connected to the AC source, when we have inductor connected to the AC source, and when we have capacitor connected to the AC source. Now let us discuss for figure 1. We know, okay, resistance do not depend on the frequency. So there is no change in current on increasing the frequency of the EMF. Okay, so we find this. Now for figure 2, okay, we have inductor having inductance L, and the graph between inductive reactance and frequency, okay, is straight line. So we find this, okay, so this is to be noted, okay. Now what we find, okay, inductive reactance XL equals omega L, and omega is twice pi F, so we have XL equals this, okay. Now for L equals constant, okay, then we find XL proportional to frequency. So if frequency increases, okay, so what we find, if frequency increases, then XL increases. So what we find, if F increases, then XL increases. So XL, which is inductive reactance, okay, this represent resistance offered by inductor, okay, it is resistance offered by inductor. So if frequency increases, then XL or the resistance offered by inductor increases. So if resistance increases, then the current decreases. So I'm writing, if the frequency, okay, if the frequency of the EMF is increased, then XL increases, okay. Therefore, so it increases, okay, therefore we can write, therefore current decreases. So we find this. Now next, okay, sorry, for figure 3, okay, what we find, the plot of XC and frequency, okay, is of this nature. So we find this, okay? Now we know capacitive reactance, okay? Reactance Xc equals 1 by omega c, and this capacitive reactance represent resistance, okay? It is resistance offered by capacitor. So we have this, okay? Xc equals 1 by twice pi Fc, and if C is constant, okay? So I'm writing for C equals constant, what we find, Xc is inversely proportional to 1 by frequency. So if frequency increases, then Xc decreases. That is, if frequency is increased, then the resistance offered by capacitor decreases. So we can write, if the frequency, okay, of EMF is increased, okay, if frequency is increased, then Xc decreases. So resistance offered by capacitor decreases. Therefore current increases. So we find this.